So this is in my notes this way. You have the balanced equation, and it says how many grams of CO2, so this is a similar one. Let's look up there. How many grams of CO2 could we obtain? So that means that is the unknown. If we reacted, and here they have 16 grams of methane and 48 grams of oxygen. Okay, what I've done here, since I'm just making this up, all I did was, we had the balanced equation already, and I said we got 10 grams of this and 10 grams of that, and how much of this can we get? Okay, now tell me what we're going to be needing before I go any further. What are we going to need before we actually do the weight? Formula weights. So why don't we, let's put them right underneath. This is the technique that I was using to keep all your numbers straight instead of having random numbers all over your paper. Okay, so known is up here, unknown is here, and I've got the units grams. Grams, 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 so we'll know what we're up against. It's going to be like this type right here, grams going to grams. Okay, we need formula weights. So let's do that first. So I've got C2H6. Bruce, what's your 30? Let's go to the nearest 10.
0.0.
Okay, give me some units.
Grams per mole.
Grams per mole. Now, if it were a question and it just had out by itself C2H6, what is the formula weight? Okay, the answer in a multiple choice format may say 30.0 AMU, or it may say 30.0 grams per mole. Either one is acceptable. But because by the time we hit this chapter 3, we're thinking on a practical level, not theoretical, of the atomic mass unit, so we want to put on gram per mole. But I just wanted you to be aware, if you're back at the theoretical level, AMU is not the wrong unit. Okay, now, we need a formula weight here. Does anybody dispute this? Because you want to ignore the 2, because this is one formula weight. Okay? Yang?
So when we calculate the formula weight, we don't count the coefficient?
No, we don't, because with this technique, the only place you use the coefficients is right in here.
Okay.
Okay, that's the only place. So, last time when I wrote this up here, I put the formula weight. I decided this would maybe make it sink in better, not to say the formula weight, but one formula weight. Okay, so it's 30.0. 2 carbons at 12 each, 6 hydrogens at 1 each for 30. Now we need this formula weight. Allison, what's it going to be? 32. Point 0 units? Grams per mole. Okay, do you see how she ignored the 7 just as she should? She's only looking at O2. Okay, now, since this is your unknown, we're going to need the formula weight of that. So, Eddie, do you have that one?
44
Yeah.
grams per mole.
Okay, point
0.
0 grams per mole. Good on your units. Now, why am I saying this point 0.0? Okay, to have your answers agree best with the answers in OWL and the answers on the test, it's probably best to always carry those atomic weights to the nearest 10th. Where that really will bite you is with chlorine, because you got to call chlorine 35.5, or you won't get an answer real close enough to make you feel comfortable if that's used on the test. Now, if it's something like oxygen, 16 or 16.0, no sweat. But you need to round, especially when it's that 0.5 issue. Okay, now we're ready to roll. Let's go with 1. And this is going to be grams of CO2. Okay, in my first set of parentheses here, Nicole, tell me what to write.
10.0 grams over 30.0 grams per mole.
Good. And this is C2H6, which is ethane. Okay, now, you looked at the units, grams divided by grams, moles of ethane come up on top. Okay, that's just like we had right back here. We're given Now, we need a mole ratio right here. Charles, what's that going to be?
4 to 2.
4 to 2. So that is 4 moles of CO2, 2 moles of the ethane. So this one's going to come up on the top, this one's on the bottom. If you stopped after 2 sets of parentheses, we know moles of CO2. Actually, if it's limiting in excess, you could go through and size up moles here, moles there, and make a decision. But since this is asking for grams, we got to go all the way anyway. So this is maybe a more tedious way, but it's a safer way. So we're going to then put in this last place, Erin, what do I put?
44 grams per mole of CO2 over 1 mole.
Okay, you could, there's a couple of ways you can write it. You can write it grams per mole like I've done here, or you can do this so you'll sure see those moles cancel. Either way, they're going to cancel. And that will leave us with grams of CO2. So, punch that through. Think about sig figs. Alex, what did you get?
29.3.
29.3 grams. Now, if this were in a multiple choice format, I promise that's going to be one of the answers. Now, that's assuming Alex's math is right. Is that what other folks?
Yes.
Okay, that's going to be one of the answers. Don't get suckered into it. You got a 50-50 chance. We got to see what the other one can do. So we got to go back and we got to do 2. Okay, this time, this becomes the known, this is the unknown. So in our first set of parentheses, right here, Steve, what are we going to write? I know this is getting pretty cluttered up. We want, this is our known, and this is our unknown. So in this first set of parentheses, what do I put, Steve?
Which ones are known?
Okay, this is our known this time. We're through with this guy. This one here. We are through with it. So, this is our known. Tell me what to do.
Put 10
Okay?
over 32.
Excellent. Grams per mole O2. And of course that gives you your moles of O2. Now, mole ratio, Tran. 4 over 7. And that's going to be 4 moles of CO2, 7 moles of O2. Unit analysis here, grams cancel with grams here back then. Moles of O2 come on top, moles of O2 are on the bottom. And we got ourselves moles of CO2. And then, Nicole in the back, what goes in this last place? 44 point, tell me units.
Grams over moles.
Good. And that is CO2, moles of CO2, moles of CO2. Let's punch that through. Liz, did you punch it? What'd you get?
7.86.
How much?
7.86.
7.86 grams of CO2. Meredith, you had a question.
Oh, no, I didn't.
Okay. Okay, now, yeah, Martha? CO2.
Oh, CO2?
Yeah, that's what we're looking for.
Right.
Maybe
Oh.
you can't read my
Yeah,
writing.
that's right.
Sorry, I'm especially messy today. Okay, now, we have this and we have this. Multiple choice format. Answer A is 29.3. Answer B is 7.86. Answer C is the sum of the two. Answer D is the difference of the two. Answer E is the average of the two. What's our answer?
Yeah.
B. This one, because you always go for the smaller amount. Bruce,
Would
question?
you phrase a question where the answer would actually be oxygen?
Of grams of oxygen,
Or just, like,
limiting and excess.
which one of the two,
Ah,
would be, you know what I'm saying?
okay, what I could say is, okay, here's your problem set up just like I had it. I could say, which is your limiting reagent?
Okay. that
And
would
if I
be
said,
oxygen.
which is your limiting reagent, what are you guys going to answer? Oxygen. Because your limiting reagent always dictates your products. Okay, and this then has to be excess. Bruce, what I thought you were going to ask me is, could this be your unknown? Not in a limiting and excess
Oh,
problem.
okay.
In a limiting and excess problem, I've got to tell you about 2 reagents. Or, God forbid, if there were 3 reagents, I could give you 3. And you have to do 3 weight ways, but I won't be that bad, okay? Because if you can do it, you know, twice, you can certainly do it a third time. Okay, so I will tell you, in limiting and excess, I'm going to give you at least 2 reagents, and I would always then ask for a product. Now, the wording can vary a little bit from problem to problem, but essentially, that's what it is. Write out your equation, you decide where the 2 knowns are, decide where your unknown is, decide where you need formula weights. Did we look at water? No, because water was never mentioned.